Let's start converting the buffer into a request. First, we should convert this byte slice here into a string slice. To do that, first we have to import the string module, or the str module actually. So from the standard library, we import str. And now we can call a function from the str module called from UTF-8. And this function accepts a byte slice, as we can see, so we can just pass our buffer. This will also ensure that the bytes in our buffer are valid UTF-8. And if we look at the from UTF-8 function, we see that it returns a result. If the conversion was successful, it will give us a string slice, otherwise we get a UTF-8 error. All right, as we know, we match on results to actually get the value or error. So we can say OK, which will wrap our, let's name it request, and this will have some body. And otherwise we will have an error wrapping the UTF-8 error, which we don't really care about. We know that if we get a UTF-8 error, we actually want to return invalid encoding from our function, because it returns a parse error, and in this case it will be an invalid encoding one. So we can directly return the error variant of the result, wrapping a parse error with invalid encoding. So this is one way to actually handle this error, and now we would have to implement all of our parsing inside of this block here. But there is another way, a bit nicer maybe, to convert the error that this function returns, which is the UTF-8 error, into the error that we want to return, which is invalid encoding. To do that, again, we can call the same function here. We pass our buffer, and now on the result that the buffer, that the from UTF-8 function returns, we can call a method called OR. And if we look at the OR method, we see that it accepts one argument, which is a result. And what the OR method will do is, if the result that we're calling it on was an error, it will actually return the result that we have passed. Otherwise, if the result that we're calling it on was an OK, it will just unwrap and return the value inside of the OK. So if this is an error, it will be a UTF-8 error, but in here actually we can put a parse error, invalid encoding, and now this will return either the correct error that we want or the contents of this function call, the string slice. This is pretty handy for converting between error types, but at the end of the day we still get a result, so we still have to actually match on this, and pretty much it will be the same. Now we have our OK, but in this case our error will actually get the error that it returns, and again we have to wrap it and return it from the function. So we didn't really simplify our code by rewriting it in this way here. I would argue that maybe using the OR and then having the almost exact same match on it makes it more unreadable. But generally, this is a very common pattern in Rust. We match on a result, and then if the result was an error, we just want to return this error from the function. And because this pattern is so common, there is a special syntax built in the language, especially for handling that case. So to see this syntax in action, let's actually yank all that and paste it down here. All right. So now instead of matching on this result, we can just put a question mark at the end, and this is the special syntax. The question mark operator will pretty much do what this match statement did. It will look at the result, which we are passing. If the result is OK, it will just return the value that the OK wraps. Otherwise, if the result is an error, we'll return the error from our function. So this is pretty cool. Now we can just say let request equals to this. And we see that our request is just the string slice because the question mark will make sure to return from the function if it was an error. There is one difference between using the question mark and this pattern match that we wrote here. And this is that the question mark will try to convert the error type that it receives if it does not match the error type that the function is supposed to return. All right, so in this case, it just sees an invalid encoding error, which is a parse error, which is what this function try from is expected to return. So it doesn't have to do anything. But if we delete this conversion, now the question mark is called directly on the UTF-8 error. And what it will try to do is it will try to convert the UTF-8 error into a parse error. And it does that by looking for a from trait implementation for the parse error from a UTF-8 error. We can even see it in the error message here. It says that the trait from UTF-8 is not implemented for the parse error. We have already looked at the from trait. It is the same as the try from trait, but for conversions that cannot fail. So now, if we go down here and implement the from UTF-8 error for our parse error, let's see how we might do that. So we implement from. Actually, first we have to import the UTF-8 error. So we use std str UTF-8 error. And now in here, if we implement our from a UTF-8 error for parse error, and what's the function that from expects? It's this one. Let's copy that. We can paste it here. So it is a function that will receive the error and will try to okay, so it will accept the UTF-8 error as a parameter and we'll have to return a parse error. We can ignore this error because we really don't care about it. We know that every time we get a UTF-8 error, we just have to return an invalid encoding error. And now when we call from UTF-8 error on our parse error, it will just generate an invalid encoding error. And if we come up here, we see that the compiler no longer complains. The question mark will look at the result from UTF-8 function. If the result is an error, it will go and check for an implementation of the from trait for the expected result error in this function and the error that it actually got. And if there is one, it will just convert it for us. And now we see that we managed to convert this code or this code into just this simple line. So we can actually get rid of all of that. And this is much nicer.